So first we talked about just identifying some of our new types of angles. And so we said if we had two lines and we had a third line that we're going to call the transversal that cuts between those two lines, then 8 angles are created. And then we gave some names to some of those angles. So for instance, we had some alternate interior angles like angles 4 and 6, and there was also angles 3 and 5, but there were only 2 pair of alternate interior angles in this situation when you had 2 lines and then the third line transversal. Alternate exterior angles, we had angles like 1 and 7 are alternate exterior, and also like 2 and 8. But again, there's only 2 pairs of these types of angles. Number 3, same side interior, we could have angles 3 and 6, and we could also have angles 4 and 5. But again, only 2 pair of those angles. Way too much. Number 4, same side exterior, we could talk about angles 2 and 7, and we could talk about angles 1 and 8. And again, only 2 pair of those angles exist. And then we get to corresponding. Corresponding, we could have angles 1 and 5. We could have angles 2 and 6, but it doesn't stop there. We could also talk about angles 4 and 8 and 3 and 7. So notice in this picture, and this is why corresponding angles are going to be such a big deal when we get into the proofs, is that every one of these angles had a corresponding angle, right? I could say, hey, if I picked on angle 6, does angle 6 have a corresponding angle? Absolutely. Angle 2 is its corresponding angle. But if I went back here and I said, hey, here's angle 3, where's angle 3's same side exterior angle? Angle 3 is in the interior. It doesn't have a same side exterior angle to match up with. So that's why we're going to make such a big deal out of corresponding angles when we do our proofs. So, corresponding angles postulate. This is something that we've talked about in class, but we haven't given this its official name, the corresponding angles postulate. It says that if we have parallel lines, so if we have parallel lines, if that's true, then mathematically corresponding angles are congruent. They are of equal value. Now, we're going to talk about the differences briefly here between postulates and theorems because they both sound a lot alike. They're both if-then type statements, but postulates don't have to be proven true. They're kind of foundational truths in mathematics. We're going to use them to help us prove theorems are true. But you can also use other theorems to prove theorems are true. You just can't use a theorem to prove itself as true. So the main reason why corresponding angles is a postulate and not a theorem is because, again, every angle has a corresponding angle. This is going to be a really helpful thing to use here. So the first proof we're going to look at, the first theorem that we're going to prove, is the alternate interior angles theorem. And it says if you have parallel lines, then mathematically alternate interior angles are congruent, that they're equal. So here's how we're going to start this proof off here. And I've already got a picture set up over here. And our given in the if part of our statement, of our theorem, is that you have parallel lines. If you have parallel lines, let's go with that assumption we do. So I'm going to draw in some parallel line markings on lines M and N, and that'll be the first part of my proof. That's the given. So I'm given that M and N in my picture here are parallel. And so if that's true, then what we're going to try to prove here is that the alternate interior angles in this picture are congruent. But I haven't marked any alternate interior angles. So what I'm going to do is mark a pair of alternate interior angles. And keep in mind, there's 2 possibilities here. I could mark angles 1 and 2, and I'm just using 1 and 2 as examples here. But these could be the alternate interior angles that we're going to try to show are congruent or equal. Or instead of those, I keep going back too far, I could talk about these alternate interior angles. Does it matter which pair of alternate interior angles that I'm proving are equal or congruent? And no, it doesn't really matter. So I'm just going to go with these 2, all right? So my goal is to show, by the end of this proof, is that angle 1 and angle 2 are equal or congruent. And I'm not going to make a big deal if you show that they're equal versus they're congruent, all right? So to start this proof, we need a third angle to help us out, because I can't just directly jump in and say angle 1 is equal to angle 2, because again, that's what we're trying to prove. So we're going to identify a third angle in this picture that's going to be able to connect to angle 1 and connect to angle 2, and then we're going to use some properties to bring those two pieces of information together. So again, what type of angle always has a partner with it? And we said before that was corresponding angles. So I'm just going to pick on angle 1 because it's angle 1, it's the first angle. I'm going to find angle 1's corresponding angle, which would be down here. Now, I'm going to use a series of what I'm going to call solid connections and incomplete connections. So I'm going to draw solid lines between angles, and solid connections means that they have a mathematical relationship, like they're equal to each other, or maybe they're supplementary with each other. I know that they maybe add up to be 180 degrees. And if I call two angles to have an incomplete connection, that means that they have a name with each other, like alternate interior, but I don't know yet a mathematical relationship. So for instance, in this picture, I would say the incomplete connection is in between angles 1 and 2. 1 and 2 are alternate interior, but what I don't know yet is that they're equal. That's what I want to show. So notice I used a dotted or a dashed line to connect angles 1 and 2. And any proof can only have one incomplete connection. So now, what's so special about angles 1 and 3? Well, they have a name, they're corresponding, but since I know and I'm given that lines M and N are parallel, well then I know by this postulate that the corresponding angles are going to be congruent, they're going to be equal. So over here in my picture is where I'm going to kind of develop my game plan for what I'm going to do over here when I write out the proof. So I'm going to connect together angles 1 and 3. There is a solid mathematical relationship. I know these corresponding angles are equal because we've been given parallel lines. And if we look at angles 2 and 3, what type of angles are they? They're vertical angles. And what's always true about vertical angles is that they're congruent to each other. They're equal. So there's a solid connection mathematically between them. And so my goal in my picture over here is to be able to connect together all of these angles into what I call basically a circuit, okay? And what I want to do is write about the solid mathematical relationships in my proof. So I'm going to talk about over here what's so special mathematically about angles 1 and 3, and then I'm going to come over and talk about what's so special mathematically about angles 2 and 3, and then we're going to use some properties to bring together those two pieces of information into one. So let's first talk about angles 1 and 3. Angles 1 and 3 are equal or congruent to each other. Again, I'm not going to make a big deal about the difference between the two. And I know angle 1 is equal to angle 3, again, because of this thing, the corresponding angles postulate. Because I said if lines are parallel, and we were given that, then this is what we may conclude. Corresponding angles are equal. So my reason is the corresponding angles postulate. And I'm going to abbreviate this a little bit here. And then what I do is I come over to my picture, and I'm going to put a little check mark in between angles 1 and 3. The check mark means that I've written about that in my proof. So I'm done with that piece of information. I don't have to talk about it again. So now I'm going to go talk about my other piece of solid information, these vertical angles. And what's true about vertical angles 2 and 3? Well, I know angles 2 and 3 are equal to each other. And the reason is because they are equal because of the vertical angles theorem. And the vertical angles theorem is one of those reasons that's on that list of 30 that I gave you that you can use. And again, I'm going to come over here to my picture and put a little check mark between angles 2 and 3 because I just talked about it in my proof. And so anytime you get two pieces of information back to back that are solid connections, that angle that's in the middle of those two pieces, which is angle 3, is now going to kind of back out of the problem. And we're going to have angle 3 back out to bring together angles 1 and 2, usually through substitution. So here's what I want you now to look at here if you haven't realized what's going to happen. If angle 1 is equal to angle 3, and angle 2 is equal to angle 3, well then that means using those two pieces of information, that must mean that angle 1 and angle 2 are equal. And you can either say this is because of the substitution property of equality, or if your brain is screaming transitive property of equality, you can use that as well. Do you have to write both? No, just pick one or the other. And our goal in this problem, in this proof, was to show that alternate interior angles are equal or congruent. And those were angles 1 and 2. And we just accomplished that. So we are officially done with this proof. Now, I would call this definitely a shorter proof, because besides the given, there was only 3 lines. This is about as short as proofs are going to get. So moving on to the same side interior angles theorem. And it says, just like our last one, if we start off with parallel lines, we need to show that same side interior angles are supplementary. So number 1, let's start with our given. And I'm going to come over here and mark these 2 lines are parallel. And that's going to be my first line of my proof. I've got parallel lines. And now what we want to show and prove is that the same side interior angles are supplementary. So first, it'd be nice if I saw some same side interior angles, if I had them labeled in my picture here. So again, there's 2 different possibilities. We could talk about these 2 angles, or we could talk about those 2 angles. It's up to you, and it doesn't matter which pair. I'm going to pick on these left ones. So there's angles 1 and 2. They're same side interior. They have a special name, but I don't know they're supplementary yet, because that's what I want to prove. So this would be my incomplete connection. Now, I need a third angle that's going to help me bring together 1 and 2. And again, what you should always try to think of initially are corresponding angles. So I'm going to pick on angle 1, again, because it's just the first angle. I could pick on angle 2 and find its corresponding angle, but I'm just going to pick on 1. So angle 1's corresponding angle is down here below angle 2. And there is a special mathematical relationship with those corresponding angles. And again, why do I know that corresponding angles are equal? Because I've been given parallel lines, so I know that's going to be true. Now, instead of angles 2 and 3 being vertical, like they were in the last proof, angles 2 and 3 aren't vertical, but they still do have a special mathematical relationship. We know that they're going to add up to be 180 degrees because of the straight angle postulate. So there still is a special mathematical relationship. So I get to connect them with a solid connection. And again, notice if I start with angle 1 is going to connect to 3, 3 is going to connect to 2, and we're going to be able to show by the end of this proof that 2 will connect to 1. So let's go talk about the 2 solid pieces of mathematical information in my picture in our proof. So first, angle 1 equals angle 3 for the same reason it did in the last problem, the corresponding angles postulate. And then come over, check mark between angles 1 and 3. I've talked about it. Then let's go talk about that connection between 2 and 3. Now, 2 is not equal to 3, but angle 2 plus angle 3 equals 180 degrees by the straight angle postulate. And again, I'm going to come over here and put a check mark between angles 2 and 3. Now, since I've talked about 1 with 3 and 3 with 2, now it's time for angle 3 to kind of back out of the problem. Now, we're going to use these 2 pieces of information and hopefully use some substitution again. So if angle 1 is equal to angle 3, and angle 2 plus angle 3 is equal to 180, well, instead of writing this angle 3 right here, what could we substitute it out with? We could substitute out this angle 3 with an angle 1. So it's not going to look exactly the same as our alternate interior angles proof, but we still get the idea that we're going to substitute out angle 3 for something else. So now angle 2 plus angle 1 equals 180 degrees. And this is true substitution. This is not the transitive property. Now, some people think, hey, we're done at this point. We needed to show the same side interior angles are supplementary, and we just showed that angles 1 and 2 added up to be 180. And those are really, really close to the same thing. But there's a little blurry line between these 2 things. Because we were asked to show that the angles were supplementary. What we've got right now is 2 angles that add up to be 180 degrees. We're going to do this little itty bitty baby step is what I'm going to call it, to finally connect these 2 together. So what does it mean that two angles add up to be 180 degrees? Well, that means that angles 1 and 2, or I'm going to say 2 and 1, it doesn't really matter the order that we say it here, is we're going to introduce the vocabulary word that we were asked to prove, supplementary. And how do I know that angles 1 and 2 are supplementary? Well, basically, we were given the definition of the word. We're now applying the vocabulary word that matches up to that definition. So it's kind of like we're using the definition backwards. And then we're officially done. So I will tell you up front that anytime that you want to talk about same side interior or same side exterior will be the same case, you're going to have to do this little baby step where if you've got that they add up to be 180, you're going to have to baby step it and say, well, that means that they're really supplementary. Or we'll use later on, if you know they're supplementary, well, what does that mean mathematically? Then a little baby step, it means that they add up to be 180 degrees. So that's all for this proof. Now, the alternate exterior angles theorem is going to be very, very, very similar to the alternate interior angles theorem. And so I'm just going to kind of go through this one a little bit faster because we don't necessarily have to spend as much time. So first, M is parallel to N, it's still our given, and you can mark that in your picture, and I need to label some alternate exterior angles. So I'll pick on these two angles. And again, I need to show by the end of the proof is that 1 is equal to 2. So there is my incomplete connection. I need an angle 3, and typically, again, we're going to use corresponding angles. So angle 3 is corresponding to angle 1 when it's right here. There's a solid piece. I know that these corresponding angles are going to be equal because I have parallel lines that were given to me. Angles 2 and angle 3, those are vertical. Vertical angles are always equal. There's my game plan and my picture. Now let's go write it. Angle 1 is equal to angle 3 because of the corresponding angles postulate. Check mark. Angle 2 is equal to angle 3 because of the vertical angles theorem. Check mark. This is where I now get to combine together two pieces of information. So again, if angle 1 is equal to angle 3 and angle 2 is equal to angle 3, combining that together, angle 1 must be equal to angle 2. Through substitution, or if you really, really want to, go ahead and call it the transitive property because, well, quite frankly, it could be the transitive property. And we're done. Now, if you compare this proof to the alternate interior angles proof, this looks exactly the same as the alternate exterior. The only difference is the picture. The picture of the alternate interior, we're inside here mostly, and in the alternate exterior angles proof, we're mostly on the exterior, on the outside. But the proof, exactly the same. So to end this kind of first half of the video, I'm going to let you try the same side exterior angles theorem. And if you think, is this going to be like the same side interior angle theorem proof? It is. So I would encourage you try this on your own. And if you get stuck, look back to the same side interior angle theorem's proof to give you maybe some hints about what we did in that. And then come back and see if you can tackle this one. So again, it's going to look a lot like the same side interior angles, except the picture is going to be slightly different. But see if you can apply that.